Hi, everyone. Thank you for joining us today. We're just going to wait a few more moments for a few more folks to sign on. Thanks. Hi, everyone. Welcome to the TBR Webinar series. Today, Senior Analyst Chris Antlitz will be discussing 5G will be an evolution, not a revolution. Before we get started, a few housekeeping notes. At the bottom of your screens, you can access the slides, audio controls, Q&A, speaker bios, and our survey. After the webinar, you will receive an email with a replay link, as well as a link to view and register for other TBR webinars. If you have any questions for us, please submit them via the Q&A widget in On24. You may also reach out to us after the event at webinars@tbri.com. Thanks again for joining us, and here's Chris to begin the webinar.
Thanks, Sarah, and welcome everybody. So every year we write a predictions special report, and it's available for general audience. Anybody can have it. We post it to our website, and essentially what we do is we post the special report, which is our predictions for the upcoming year. And what we do is every group at TBR derives a webinar deck based on the key findings from that special report. So that's exactly what we're going to be talking about today. So I'm going to be discussing the 2019 predictions that the Telecom group at TBR is looking at for this year, not only this year, but also a little bit forward-looking as well, even beyond this year. The topic of this year's report was 5G will be an evolution, not a revolution. So, 5G permeates everything, it seems. It permeates not only the telco ecosystem, but it's now transcending the enterprise ecosystem. And it's also going to start impacting the consumers around the world. This is going to be a global phenomenon as it plays out. It's going to take some years for this to play out, but we're at the very early stages of this. So we're going to be talking a lot about 5G in this webinar. And yeah, the theme is evolution, not revolution. So my name's Chris Antlitz. I'm in the telecom practice. There's my email and Twitter handle if you want to follow me or shoot me an email. Before we jump into the content, I do just want to state that we have a research portfolio or report portfolio in the Telecom group at TBR. This is the list of reports, and a lot of the data and the charts that you're going to be seeing is derived from some of these reports. So we cover everything from individual vendors to individual operators, edge compute, IoT, all those areas are covered by our group. So let's jump into the content and set the stage before we get into the predictions. So 5G era has officially begun. It started in October 2018. Verizon was the first operator in the world to deploy a commercial 5G service, and it's called 5G Home. It's a fixed wireless access offering. They started offering service in 4 markets in the States, 4 cities in the States. So that, to us, marks the beginning of the 5G era. And what we're going to see over the next couple of years is this market is going to get off to what I'm calling it an underwhelming start, but a strong finish. So we're going to unpack what that means in upcoming slides. But essentially what that means is that 5G is initially going to be utilized for traditional use cases of the network. So think enhanced mobile broadband and fixed wireless broadband. So an alternative to fixed broadband. So if, for instance, if you get internet service from a cable co, now you might be able to get a similar quality of service from a telco that is offering a 5G fixed wireless offering. That's exactly what Verizon's done. So that would be an example of that use case. So initially, so that's this year and next year, that's what we're going to see in 5G, and that's globally. Once we get beyond once we get into the early 2020s, we're going to start to see B2B type use cases and new revenue streams emerge for telcos. And we're going to get into that in upcoming slides. But for 2019, it's traditional use cases of the network. We're going to see operators accelerating their 5G deployment timelines and broadening the scope of these deployments. And they're doing this predominantly to realize the cost efficiencies. So this is a cost play initially. It's about how do we support traffic growth more cost effectively. So 5G is up to 10 times more cost efficient on a cost per gigabit basis compared to LTE, up to 10 times. So if you're a telco and you're seeing your data traffic growth increasing at a double-digit rate every year, and you only have so much spectrum, and you only have so much capital to put into CapEx to continue building out infrastructure, 5G is extremely attractive. So this is the key reason why telcos are going to be deploying 5G, particularly for enhanced mobile broadband, over the next couple of years. 5G is going to push operators to accelerate and broaden their network transformation. So cloud and virtualization are foundational to this architectural change to the network. And we're going to talk about that. That's actually prediction number 2. So we're going to get into that in more depth in a couple slides here. And then new revenue will come from 5G, but it's not coming anytime soon. We're looking at around 2022 time frame, early 2020s, we're going to start to see some commercial services that are generating revenue for telcos. Until then, we're going to see a lot of experimentation, a lot of trialing, pilot projects, but we're not going to see commercial revenue being generated, so B2B revenue generated until that time frame. So let's look at this in a diagram. So what we have here is the global adoption curve. This is global. Some markets are moving faster than others. The States is moving faster than this curve is showing. And we also have Korea is moving faster. China is expected to move faster. And then we have Japan is also going to be an early adopter here. So, but generally speaking, this is what the adoption curve looks like globally. So by 2022, we're going to have mainstream adoption of 5G. So what that means is we're going to have nationwide 5G availability in many developed markets, and some emerging markets are going to be ramping up their build-outs in that time frame. The early adopters and early majority are going to be those markets I mentioned before, those 4 countries. That's where we're going to see the first nationwide deployments of 5G. T-Mobile's been very vocal about this. AT&T has also been vocal about this. Other companies are also trending towards a nationwide deployment in that time frame. In Japan, in Korea, the Chinese, there's some wild cards there, but if they get the stars to align there, we could also see a very rapid nationwide deployment of 5G once they get all their ducks in a row in that market. And then we have late majority and laggards. You're looking at the mid-2020s. Anybody that starts deploying 5G in the mid-2020s, in our book, is going to be a laggard. And that's just based on the roadmaps we're seeing telcos aligning with. It's aligned with how the specs are moving out, ecosystem development. That we're very comfortable that that's going to be the adoption curve that's going to play out based on what key players in the market have specified. The bottom diagram is what 5G use cases will become commercialized and when. So the way we did this is we parsed the market in 3 distinct phases, phase 1, 2, and 3. So basically what we did is we took the adoption curve and we segmented it into 3 distinct categories of market development. This is how we see the ecosystem, the market is going to play out over the next 10 years. So phase 1 is what I call status quo. So status quo is we're going to use 5G for enhanced mobile broadband and for fixed wireless. So this is traditional use cases of the network. It's going to be better service for the end user. So if you get a 5G smartphone, it's going to be better than 4G smartphone, right? Your quality of service, that experience is going to be better in terms of faster speeds, lower latency. That's what it's going to look like for the end user. And then for fixed wireless, you're going to have a price competitive offering that disrupts the traditional fixed high-speed internet market. So that's going to be status quo. That's phase 1. Phase 2 is when things start to get interesting. I'm calling it the network renaissance phase. Renaissance in the sense that 5G is going to be an enabler for Industry 4.0, so the fourth industrial revolution. It's going to drive digital transformations. It's going to drive dramatic differences in business models and in society. So think like smart cities, autonomous driving, these paradigm shifts in fundamental aspects of society. We're going to start to see that become a reality in the mid-2020s, early to mid-2020s. I think some markets we're going to see very proactive here. Markets like Singapore, Hong Kong, China, the States. These are markets that are going to be ahead of the curve in coming out with some of these very transformational, society impactful type use cases for the network that were not possible before. Phase 3 is when we get to ecosystem maturity. So by that stage, we're going to see autonomous vehicles widely utilized on public roadways. So transport trucks, 18-wheelers, a lot of those are going to be unmanned in the future, or they'll be hybrid manned. So you'll have someone in the bed of the truck, but they might not be driving all day. So at night, the truck might turn to autonomous mode because there's not as much traffic on the road, not as much congestion, but during the day, you might have a manual driver. That could be what we would see in the future. This is right around the corner, by the way. Companies like Amazon, and there's some others out there, are actively testing these technologies now. If you guys do a search on Google for Amazon trucking autonomous, use those keywords, they're actually doing pilot tests on some roadways in Seattle on the highway system there, testing how they can do last mile fulfillment and how they can optimize their package routing system. So this is a big deal, big deal, hugely impactful to society. 5G can help enable this. It's a key enabler of these types of technologies and these use cases. We'll also see some sci-fi futuristic things like remote surgery, maybe haptics, enhanced virtual reality type environments for gaming. We're going to start to see those very sci-fi-ish type things. Think Minority Report, if anybody's seen that movie, where he has his hands up, Tom Cruise has his hands up, and he is using haptics, changing digital screen in front of his face to, it's like a computer system that is symbiotically controlled by his hand movements, his gestures, and his eyes. That 5G enables that. So this is a big deal. And we're going to see a lot of innovation over the next 10 years to make these things a reality. Okay, so I'm getting way ahead of 2019, but let's bring it back a little bit and talk more this year and next year in terms of what's going to happen. Let's bring it a little bit closer to home here and make it a little bit more realistic for 2-3 year planning for companies, and that's what our predictions are predicated on here. So we're going to look at the first prediction. The first prediction is around the cost points of 5G and the justification to invest in 5G. So let's go back in time to start off here. When we went from 3G to 4G, that was driven by everything's moving to all IP, so traffic's moving onto the internet. Everything's becoming, instead of circuit switched, it's becoming packet switched. So there was a change in the architecture, the protocols of the network. It was more efficient to do this. The inception of the App Store facilitated this. It was a key driver in this on the smartphone platform. And networks had to align with this. So everything became data. Voice is now data packets, right? Whereas before it was circuit switched. So we see this, right? We see this evolution in the network. So 5G, what does 5G bring to the table? Why should telcos, after investing hundreds of billions of dollars globally on 5G spectrum and infrastructure, why should they now spend again on 5G infrastructure and spectrum? Well, it enables them to not only optimize their traditional business, so providing mobile broadband and fixed broadband, so delivering that wirelessly, but it also opens up opportunities to sell new use cases of the network, whereas you might not be able to do that with 4G. So one example is mission-critical IoT, where you need a low latency connection at a high reliability in order to realize a certain use case. So think of something like autonomous driving. You need latencies to be low as possible so that you can do accident avoidance in an optimal way, just as one example of that. So, but first phase, it's about cost efficiencies. So 5G is better than 4G, all right? It's better from a end user performance perspective, but it's also better for a telco because it's more cost efficient to carry the packets. And it's also an opportunity for them to market a new service. So there's a marketing element to this too that shouldn't be discounted. So the telcos, and we have a spend curve there, this is adoption. That's global spend, by the way. So that's RAN, that's the 5G new radio, 5G core spend, and associated product attached services. That's all we're showing there. So fiber investment, all the backhaul stuff. For simplicity purposes, we did not include those numbers in that spend forecast. So I just want to make sure everybody's on the same page with that. If you add in the full architectural change to the network, those numbers would be way higher. It would be tens of billions, potentially even exceeding $100 billion per annum on a global basis. That's tied to 5G, the re-architecture of the network to be 5G oriented. Okay, so that's prediction one. Prediction two is building more on the transformation aspect here. This is not just about putting out a new radio interface, right? 5G's new radio interface, 3G PP spec, it's better than 4G. That's great, but there's a much broader lens that 5G needs to be viewed behind, because you can just do the radio and that's fine, but if you really want to have a 5G network that's robust and dense enough to support new use cases of the network at the low latency and high reliability that's required, you need to enhance your backhaul, your transport, your routing, switching layer. You need to enhance your spectrum depth. So you need to use things like carrier aggregation, leveraging in mid-band, high-band spectrum. You need to invest in virtualization, orchestration platforms. So you need to invest in the cloud, so virtual RAN, a virtualized core. These are all investments that will be required to build a foundational 5G network that can support and enable these types of use cases. Some people in the industry call it network slicing. So that's one way you could look at this. In order to do these things in the best way possible, the most cost-efficient way possible, as well as meeting requirements of end users, you need to think about your network end-to-end, not just the radio interface and upgrading that. So actually, these two graphs I have here are a more comprehensive view of the end-to-end transformation required for a 5G network, a true 5G network that can support these new use cases. So the first graph on the left tells a story here. The totality of the bar is total CSP spend on CapEx plus external OpEx. External OpEx is OpEx that is addressable to vendors. So that's things like maintenance services, managed services, systems integration type services that are not capitalized. So I added those two numbers together to get a more holistic picture of what is the market opportunity here, what kind of spend are the operators investing to do this. So the dark orange bar is the new spend. So that's the new architecture of the network. That's the new way of doing things. The light orange spend is the old way of doing things. So that's the traditional way of architecting a network. That's legacy technology-oriented spend. So as you can see there, and then on the graph on the right, in those green bars is an extrapolation of the dark orange. So it's the same numbers, but I extrapolated it to show it in a different way. So as you can see here, by the time we get to the year 2020, what we're saying is over $100 billion of aggregate CSP CapEx, global spend, is going to be allocated towards this network transformation. So things like NFV-SDN, AI, automation, all those things, the cloud, all those things wrapped together are in those spend numbers. And 5G is going to accelerate that because of the reasons stated before, right? You need a robust foundational network, not just the radio interface. You need the entire end-to-end network to be upgraded and re-architected so that it can support some of these use cases at scale. Okay, so that's prediction 2. Prediction 3 is about fixed wireless and disruption in the broadband market, for high-speed broadband specifically. So that's what we're talking about here. So the two images on the bottom, the first one on the left is a fixed wireless model. So that's what fixed wireless looks like. It's a point-to-point signal transmission. It's wirelessly transmitted, the signal, from a radio to a receiver that is on the premise. It could be a household, it could be an enterprise premise. The signal, usually line of sight, it could be non-line of sight, but if it's line of sight, you get a higher throughput, so you can get a gig or more downlink speed. So that's what the system looks like, and I have an image there of Verizon's fixed wireless offering, 5G Home. The reason I put that in there, that's the first that's the first offering here. That's what it looks like. So that's their CPE equipment is what you see in that image there. So that's actually the router that would be residing inside of the consumer premise. That's what it looks like. So I think fixed wireless makes a lot of sense. I think that this is going to be hugely disruptive to the fixed broadband market. I think the cable guys are taking this seriously. Or they should if they're not. I think there's a lot of debate in the industry that, fixed wireless, yeah, it's great, but it's probably not going to work as well as people think. Based on the things that I've seen, I would beg to differ. First of all, LTE fixed wireless supports many millions of end users, not only in the States, but also globally. And it works pretty good. It's better than DSL. And there's an upgrade path to 5G, which has the potential to offer a gig or more speed. So, deploying fixed fiber to the premise is cost prohibitive in the last mile, but there's a lot of fiber backhaul already in these footprints. So essentially, it makes a lot of economic sense to do this because if you can eliminate the cost impact of delivering, of rolling a fiber out, digging up someone's backyard and laying a fiber cable and commissioning that up, and you can just go over the top with a wireless signal, to me, the economics make a ton of sense. And I think we're going to see tens of millions of households in the States ultimately be offered this solution. I think we're going to see many, end users take up on this, especially millennials. I think they're very well geared towards consuming a service like this. And I think that in Europe, places like Europe where it's prohibitive to dig up cobblestone streets in major cities that are, hundreds of years old, to retain the integrity of the history there. If you go over the top with fixed wireless, that makes a ton of sense. Even if the speed's not as good as going full fiber, just for the mere fact that it works around some of the regulatory zoning permitting issues, that's hugely attractive to telcos, to end users, and to regulators that are looking to increase speeds to the end users. The telcos need a better delivery mechanism to do that more cost effectively. So I think that fixed wireless, so first of all, this is not a new thing. Fixed wireless has been around for many years, right? I think the industry over time has worked through a lot of the technical challenges that made fixed wireless not feasible in the past. So LTE Advanced and 5G address many of those shortcomings, many of those shortcomings. And based on some of the real life use cases I've seen of these things in the field, as well as demos and whatnot, this makes a lot of sense for end users. And I think that it's also able to be price competitive with fixed offerings. So, for instance, if you have say you have one de facto fixed broadband offering in your market, right? And typically a cable co if you're in the States. And if you have a disruptive telco come into a market with a fixed wireless offering and they're offering service that's comparable, maybe not as good as, but comparable to the cable offering, but the price point is lower than the cable offering, all of a sudden you have a situation where there's real price disruption in the market, and it's a market share grab on the part of the telco. To me, this makes a ton of sense in many situations, maybe not all situations, but keep an eye out for this. I think we're going to see many millions of households take up on this in the States in particular, and then in Europe we're going to see a very high uptake of these services over the next few years as people wake up to the reality that this makes sense, the technology is here, it's available, it works really good, and the price points are attractive. Okay, so that was the 3 predictions. So I'm just going to do some key takeaways and we're going to open it up for Q&A. I see there are some questions already in the queue. So if anybody has questions, just add those to the queue as I go over the key takeaways here. So we're going to start off with 5G is going to be an evolution, not a revolution. So as we've seen in the adoption curve, in the use case curve, those phases, 5G is not going to happen tomorrow. It's going to take time. It's going to take years to build out the infrastructure. It's going to take years for the use cases and the ecosystem to build out to an extent where it radically changes societies and fundamentally changes businesses. We're going to get there, but there's a lead time to getting there. That's what I want to stress here. There's a lead time. It's not imminent. It's going to take time, and there's a lot of very smart people globally that are working on these things, trials, and academia is working on this. There's partnerships, collaborations across industries that are all trying to figure out how to commercialize these services, how to fine-tune the technology, and how to get some real critical mass here. But again, it's going to take time. There's also lead time for telcos to accelerate their network transformation. So you don't just wake up tomorrow and surprise you have a network that is fully virtualized, it's cloud native, it's leveraging white box architectures, resembling like a web scale type environment. This takes time. And we're going to see these things accelerate, yes, but it's going to take years for the telcos to fully migrate their legacy to the next generation architecture. So I'm calling it underwhelming, but if you think that we are going to see 5G matriculate throughout the traditional use cases of the network, that's great. It's going to permeate those use cases, and that's great for the next couple of years. When we get to the 2020s, that's when we're really going to see Industry 4.0 take off. Again, there's a lead time to getting there. And so it's going to be early 2020s. That's when things get real interesting globally in the 5G ecosystem. We're going to see some really big changes taking place in the world. If anybody here is going to Mobile World Congress, or even if you're not going, there's going to be a lot of press releases and announcements that are going to come out over the next few weeks. Companies are going to be announcing all kinds of use cases for 5G, things they've been working on. It's going to give us a more updated glimpse into where this is all going, and we're going to see some of these innovations on a world stage, so be showcased. So, keep an eye out for those things. Some of the use cases that we talked about on this call, you're also going to see some tangible demos of those things. Many of those will be showcased at Mobile World Congress this year. Okay, so that was the content for this call. So we're going to open it up for Q&A. There's a lot of questions in the queue, so we're just going to go one by one. And I'm going to start here. So I'm going to read out the question and then answer it. So the first question is, last year you made a well-supported case that 5G would stress the balance sheets of the providers and had a limited set of use cases, fixed wireless being the poster child. How has your thinking evolved? So the thinking is still very much aligned with that. A couple of things have changed. So there's been some revelation since then. So first off, in terms of use cases, we talked in last year's call about fixed wireless and enhanced mobile broadband. That has not changed. Those are still the predominant initial use cases for 5G, and they will be this year and next year. When we get to the early 2020s, we will start to see new use cases of the network emerge that are commercialized, right? Not just demos or pilots. We're going to see actual commercial models around the use case, a business case around it. So in terms of the finances, one of the things that we're seeing in the market, so technology is innovating and innovation cycles are compressing. One of the key things we've seen this year is that RAN vendors have made their RAN platform seamlessly upgradable to 5G. So what that means is that every historical G, every new G that came out, you needed to invest in a forklift upgrade. You needed to put out a new hardware in the field nationwide, and you needed to turn it on at scale to have new coverage in the new G. So 2G to 3G, 3G to 4G, that's what happened. 4G to 5G is different. Yes, in some instances, telcos will need to put new infrastructure in the field, new physical infrastructure. For some telcos that are using the advanced RAN platforms, such as Ericsson's ERS system, that RAN is seamlessly software upgradable to 5G. So what that means is you can leverage your existing LTE infrastructure, which has already been invested in. You can remotely download a software upgrade onto that physical infrastructure, and you can have a 5G footprint from day one. That's a paradigm shift in how networks have historically been architected. And by the way, these RAN systems have been widely deployed as the telcos built out their LTE network. So companies like T-Mobile, as an example, most of their LTE footprint leverages software upgradable RAN. So when they make a statement that they're going to have nationwide 5G coverage in low-band spectrum by the end of 2020, that statement is backed up by the fact that they are planning a massive software upgrade across their entire network footprint to upgrade their LTE network to 5G. So this is a paradigm shift. So will it stress balance sheets? In some instances, it will, especially if a company needs more spectrum. They have to pay for that spectrum. but you do have to pay for the software upgrade. It's not free. But in terms of the load from the forklift upgrade aspect of evolving from 4G to 5G, it's going to be a magnitude cheaper. And again, this comes back to the original statement about the cost efficiencies. It's not only more cost efficient from an OpEx standpoint, it's also more cost effective to go from 4G to 5G from a CapEx perspective, based on the software upgradability of the RAN, and also other innovations in software that make it more cost effective to do this. Okay, so the next question is, are the figures in millions or billions on slide in those charts? So if you look at the y-axis, it should specify. I'm going to go back to a chart here. And so this is in millions, and this one's in billions. So yeah, they're different. So one's in millions and one's in billions. So if you look at the y-axis on the charts, it will specify what that is. Okay, next question. What is the timeline for wireless 5G to disrupt the traditional fixed access business model? Early adoption, is it mainstream? How will fixed wireless compete on cost? Okay, so these are great questions. So, timeline for 5G to disrupt the traditional fixed access business model. So it's already started. Verizon started this, right? It's already happening in the 4 cities they started building in. They're going head-to-head with incumbent telcos as well as the cable guys. So it's already happening. It's going to scale. Other companies are planning to do this at scale. There's operators in the UK, in Romania, in Germany. There's a few other countries that they're public. Switzerland, that's another one. So it's over the next 2 years, I would say, tens of millions of households is a small number, I would say. If you aggregate up globally how many of these POPs could get covered or actually be on the service, it's a very high number. And part of the factor is some of this infrastructure, it's some of the software upgradability aspect. There's a time to market advantage to getting this infrastructure in the field. There's different variables that are at play here that could dictate speed to market by certain telcos. It depends on their asset composition. It depends on their spectrum configurations. But it's going to be hugely disruptive. I would say this year we're going to see an early glimpse of, early take on, is there market share shifting? 2020, we're going to see some needle-moving events where we're going to see actual, I would say, market share that is measurable in earnings results. We're going to see actual market share starting to shift to companies that are aggressive with fixed wireless. And then that will scale from there. So it's going to continue to accelerate through the early to mid-2020s, I would say. In terms of cost, so the biggest cost for CapEx for FTTP is the last mile. So it can be cost prohibitive. There's also zoning and permitting issues. There could be topology issues. So if there is an encumbrance to deploying that cable, that fixed line, that could be prohibitive. So fixed wireless, you can go over the top of the problems. And so, yeah, it's more cost effective. You can also, there's some new innovations in spectral efficiency and in how you architect those beams. So this, on the engineering side, where you don't even need line of sight anymore to get, 100 megs or higher on the downlink. So that's hugely attractive. Some people don't need a gig. A lot of people don't need a gig of speed. If they had 100 megs, as an example, that might be more than sufficient for their consumption needs. So there is a strong case to be made where you could even leverage existing macros on towers using mid-band spectrum to radically change the cost points of delivering fixed wireless. T-Mobile's looking to do this, by the way, and they've been very public about this, by the way. There's a lot of documentation in the market about how if they merge with Sprint, they will be able to leverage Sprint's 2.5 spectrum, which is a mid-band spectrum, to provide a fixed wireless broadband type offering across roughly half of the households in the state. So you're looking at around 50 million or so households across the state. That's a rough figure, by the way. That's a back of envelope calculation based on some of the triangulation points that they've given. So this is hugely impactful here. These are big numbers. And the cost, it's an incremental cost. It's not a huge cost because you don't need to deploy the cable through the last mile. You're leveraging an existing macro base station to spray the signal. The cost points make a ton of sense when you do that. Okay, the next question, any TCO figures on mobile 5G versus 4G? So 5G is up to 10 times more efficient on a cost per gigabyte basis compared to 4G. Now that depends on the asset composition and the topology. So there's a lot of variables to get to the 10 times. Most telcos will not get to a 10 times efficiency. They will not. And most telcos will get several times efficiency. The point I want to make here is it's an efficiency gain. It's an incremental uplift in cost to get that, to realize that efficiency gain. That's the justification. That's the business case early on to do the investment. So as an example, if you deploy 5G in low-band spectrum, low-band being under 1 gigahertz, from 4G to 5G, you get about a 20% efficiency gain like for like from 4G to 5G. So that gives you kind of an idea of what kind of efficiency gain you can expect on low band. As you scale and leverage things like carrier aggregation with higher spectrum bands in mid-band and high band, that starts to change you start to get efficiency gains that scale from there. So you might get 5 or 6 times efficiency gain. So it's, given the incremental cost uplift, the benefits far outweigh the incremental cost to do this. And this is, in my mind, our research is suggesting that this is the key justification point why we're seeing telcos around the world making formal commitments to deploy the 5G faster than we're seeing business cases become available in the B2B space. So it's the traditional use cases of the network. It's doing it more cost efficiently is the key justification point for phase 1. Okay, so the next question is, what is your thinking about edge compute build out to support services? Look to telcos or startups such as Vapor.io. When will the hyperscalers get into this directly? So edge compute is part of the re-architecture of the network, and edge compute is also a critical component to addressing latency requirements and network slicing requirements for some of these use cases. So edge compute is going to naturally be built out. Again, this is an evolution, not a revolution. So edge compute is going to start being built out closer and closer, pushing those compute resources closer and closer to the edge of the network as it's economically feasible, right? Build it and they will come. That mentality probably won't work out so well. But if there is a business case for it that's going to justify the infrastructure investment, then we're going to see edge compute build out and align with those business cases. There are some startups such as Vapor.io that you specified. They're working with ecosystem partners to address the economic side of the equation. Again, this is emerging. This is where the early phases of this playing out. I'm actually going to be doing a webinar on edge compute later this year, probably in the fall timeframe, or summer timeframe. So keep an eye out for that, where we're going to be deep diving on edge compute and use cases and cost points, economics of edge compute. I'll put a pin in it for now, and we'll come to that webinar. Next question is, do you see telcos becoming real solution providers, perhaps displacing cloud providers like AWS? So the more sophisticated telcos, the ones that buy IP, so that either acquire IP or develop IP internally, that transition into new business models such as analytics or leveraging data, monetizing data in different ways. Those are the telcos that I think will be able to compete in non-connectivity areas of the value chain. I don't think it's going to be many telcos. I think it's going to be the leaders that are going to be able to do this at scale. Verizon, AT&T, NTT, Vodafone, those are the telcos I would keep an eye on that are doing that. So yeah, will they compete? I think it's going to be more symbiotic. There will be some co-opetition, but the ecosystem, there's going to be a lot of collaboration between the telcos and the web scales in those areas. Okay, so let me go to the next question here. So in your opinion, how will telcos leverage 5G to enhance experience in providing content to consumers? So yeah, so again, 5G is a delivery mechanism, so you can deliver packets wirelessly more efficiently, better user experience. So video, you could have, video could extend to AR, VR type experiences. It could be traditional broadcast type service, could be gaming, traditional cloud gaming. There's different ways it can manifest itself. 5G really just enables true mobility, where you can have an experience outside of the confines of a premise, where you can take it on the go. So that's really the key, I think, there. Otherwise, you'd want to use a fixed connection because you're going to get the best performance on a fixed connection. Fixed, and when I say fixed, I'm not talking about copper. I'm talking about either DOCSIS 3.1 or FTTP. Okay, next question. Is the shift to 5G for fixed wireless mainly consumer or commercial? How will this change over time? So mostly consumer. The vast majority of the adoption we're going to see by end users for fixed wireless is going to be consumers. Enterprises, it's a little different. We're going to see some small office, home office go to fixed wireless, but I think when you look at, medium-sized businesses and up, bigger ones, they have unique needs, and I think that in some cases they will use fixed wireless, but I think their workload requirements, their needs for consistency of performance, it's going to keep them stuck with fixed broadband. I don't think we're going to see many large enterprises make a big pivot towards 5G fixed wireless. Their needs are different. But consumers, absolutely. Consumers, especially millennials and the younger generations, they're very susceptible to buy these types of services. They understand it and they're willing to try it. They tend to be early innovators, early adopters of these types of technologies. So I would keep an eye on that. I think that's all the questions. Yep. Okay. So that's all the questions. So thanks for joining. Again, I'm going to be giving more webinars throughout the year. There's going to be a webinar on NFV-SDN. There's going to be a webinar on edge compute later this year. And we'll have some other topics as well that we'll be providing over the year.
All right, everyone, please feel free to reach out to Chris with any follow-up questions. If you have a few moments, we would appreciate if you could fill out the survey on your screen. A replay version of the webcast will be available after the event and will be sent out to you via email. To view a list of our upcoming and past webinars, please visit tbri.com. Be sure to join us Wednesday, February 20th for Customers Care Less, Vendors Buy More, and Both Sides Become More Intelligent. Thank you and have a great day.